What actually is a force? A force is a push, or a pull. It's an interaction between two objects. Here's a push. The box moves. And here's a pull. Same idea, the box moves. A force can change. Its speed, like slowing something down. Its direction, like turning a path around. Or its shape. The unit of force is the Newton, capital N. 1 Newton is roughly the weight of a small apple, about 100 grams. Here's a puzzle. Must two objects touch for a force to act? Sometimes yes, and sometimes no. That splits every force into two families. Contact forces, the objects must touch. Field forces act through empty space across a gap. The charges pull toward each other without touching. You need to know 9 forces by name. Weight, gravities pull on a mass. Normal, the push from a surface. Friction opposes sliding between surfaces. Drag resists motion through a fluid. Air resistance, drag through air. Tension, the pull in a string or rope. Thrust, a push that drives you forward. Electrostatic, forces between charges, even across a gap. Magnetic, forces between magnets or magnetic materials. 2 key clarifications. Air resistance is just drag, specifically through air. The contact force is the normal reaction, the push from a surface. Kill these misconceptions. Friction is not always bad, it lets us walk, grip and brake. Air resistance is not always big, it grows with speed, often tiny when you're slow. Weight and mass are not the same, mass is amount of matter, weight is gravity's pull. An object at rest still has forces, a resting book has weight and normal, and they cancel. Quick challenge. Can you sort them yourself? Here are the 9 forces. Contact on the left, field on the right. Each force flies to its family. So how do physicists actually draw the forces on an object? How do we draw the forces on an object? With a free body diagram. One object, on its own, with every force acting on it drawn as a labeled arrow. Golden rule, forces on it, not forces by it. 5 steps, every time. The 5-step method, a book resting on a table. Isolate the object, find each force, draw it from the body, label it, and make bigger forces longer. Here's the book on the table. Step 1, isolate the object. Step 2, find every force on it. Weight pulls down. Step 3, draw arrows from the body. The normal pushes up. Step 4, label each force. Step 5, equal arrows mean balanced forces. Now 3 more free body diagrams. Build them yourself. A mass hanging on a string, weight down, tension up. A box dragged at steady speed, 4 forces. Weight and normal cancel. Pull and friction cancel, that's why speed stays steady. Classic mistake, drawing velocity as a force. Motion is not a force. A ball falling through air. Weight is longer than air resistance, so the ball speeds up. Longer arrow means bigger force.